A warm welcome. This is Electric Energy Generation, Utilization and Conservation course with the lecture 3.1 focusing on role of electric heating for industrial applications. Electric heating is a process of heating using the electricity. This is where electrical energy is converted into heat energy. Common applications include the heating of buildings, cooking process and industrial processes, etc. An electric heater is an electrical appliance which is used for converting the electrical energy into heat energy. Normally, which is creating that heat means the heating element which is used in electric heater will be of resistance type. It's a resistance material, and if suppose electricity is passed over that resistance material, obviously it will create a heat due to the I square R loss, that's Joule heating. Alternatively, if suppose a heat pump uses an electric motor to drive a refrigeration cycle, drawing heat from a source such as a ground or outside air and directing it to the space to be warmed. When current is passed through the conductor becomes hot and the magnetic material is brought in the vicinity of an alternating magnetic field. In such a case also heat is produced in the magnetic material. Similarly, it was found that when an electrically insulated material was subjected to electrical stresses, it too is undergoing a temperature rise. So we are having three different types of heatings. Why do we prefer electric heating over the other types of heating is first is cleanliness. We do not burn anything. Second is ease of control. If suppose we want to stop, just we have to switch off. And next is uniform heating. Since electricity passage will be throughout the entire surface, there occurs uniform heating. And next is low attention and maintenance cost. Obviously, when considering the normal heating process, electric heating, it requires low attention and maintenance cost. Proper designing of socket and the connections is, if it is made, then the maintenance is less. And also the labor charges on these items are negligible because there is no requirement for any labor charge. Just you are going to switch on and off the electricity. The role of electric heating for industry applications are vast, and not only in industrial purposes. For domestic also, it is nowadays electricity usage, electric heating usage is vast. First one, the hot plates for cooking. Next is immersion heaters for water heating, electric toasters, popcorn plants, room heaters, electric irons, electric ovens for bakeries, etc. These are the places where electric heating is used. Next, in for industrial activities like melting of metals, molding of glass, enameling of copper wires, heat treatment processes, baking of insulators, and welding, we normally use this electric heating process. There are n number of advantages. First is the process is completely automatic, so it automized, so that regular what is it? We have to watch whether it is good or not, whether it is fine or not. Continuous involvement of any human is activity is not needed. So this will improve the efficiency, and it creates a better working environment, and also it is safe, and the response is immediate, and so there is no wastage of any time or money there. It is a simple and most accurate control when it is subjected to automation rather than manual process. The system does not create any flue gas because there is no manual heating, and since electrical heating is used, the environmental degradation is completely eradicated here. It's a clean system. The cost can be minimized to a greater level. While considering the role of heating for industrial applications, the requirement of the heating material are the resistance should have low temperature coefficient. Only then, with the small temperature rise itself, it will produce large amount of heat. Second, it should have a positive coefficient of resistance. Only then, when heating is, I mean, when positive coefficient of resistance in this, when resistance increases, obviously the heat increases. High melting point. high specific resistance, high oxidizing temperature, it should withstand vibration, and it should have adequate mechanical strength. So these are the requirements of any heating material. While considering the modes of heat transfer, we know it is conduction, convection, or radiation. Conduction is the process of transfer of heat between the solids. Convection is through the liquid or the fluid, and radiation is nothing but the passage of heat over the gas medium. While considering the types of heating, it is either power frequency method or high frequency heating. In power frequency method, it is direct resistance heating, indirect resistance heating, direct arc heating, and indirect arc heating. While it is direct resistance or indirect resistance, we'll be using the filament type, right? In case of arc, we'll use carbon arc, where the discharge of electricity will be taking place. And next one is a high frequency heating, which involves induction heating and dielectric heating.